Hello.
Alright, let me give you the link. Um, let's see here. Alright, so what do you want to work on? I was thinking about finishing up the multiple choice, or what do you think? Or do you have
Yeah,
like
let's finish multiple
questions?
choice.
Okay, because we left off on, I think, question 30?
Yeah.
Okay. So how do you feel? The test is this week. How do you feel?
To test?
Yeah,
You mean other tests I took?
the AP stats test. Like, are you ready for it? Do you feel prepared?
I mean, feeling okay.
Okay.
Yeah.
Alright. Do you have it up on your end?
Yep, I have
Okay.
it.
Alright, so we're gonna start on question 30 or 31. Which one was it? I think we left off on 30, so we're on 31.
Sure. Let me
Okay.
see. Thirty, 31.
A large number of random experiments were conducted to determine whether taking a particular drug regularly would decrease the chance of getting a certain disease. Are you there?
Mm-hmm.
Alright. Do 31 and tell me when you have the answer, and we'll talk about it.
Okay.
For each of the experiments, the drug effect is the difference between the proportion of people taking the drug who got the disease and the proportion of people taking a placebo would get the disease if the drug had no effect whatsoever. Which of the following experiment results would be anticipated?
What? When 95% confidence interval for the population drug effect are constructed, those confidence intervals include 0 about 95% of the time. I'm not sure. I mean, the all of them looks good.
Okay, so walk me through the logic for number one, right? P value would be greater than 0.05.
Yeah,
Why do you say
because the
that's
question
correct?
says the drug has had no effect,
All right,
so
that's correct.
mm-hmm.
Okay. What about two? There will be an equal number of experiments showing positive and negative values of the drug.
Oh, this one, equal number of experiments showed. Yeah, what does this one mean?
So here they're going to, the type of test that they're probably doing here is probably a chi-square because they're looking for proportion. Okay.
Mm, okay.
And when they're talking about an
What is
equal
this
number,
chi-square?
hmm?
I think it should be two sample z-test.
Okay, two sample z tests. Why?
because we have people who take the drug and people who take the placebo.
Oh, okay, yeah. Two. All right. So when you do the test statistic, they're going to be calculating. Okay, you're correct. I'm giving you the wrong answer. Two is assuming it's a chi-square test, and you know how the chi-square test is a like value subtract the expected value,
Uh-huh.
right? That's what this is, the positive and negative values of the drug. So it's like the first person might have like a positive value, then you subtract that from the expected mean, then you
Mm-hmm.
square that plus, then you go to the next one. If they have positive, then the negative, subtract that from the expected value, square that, right? Remember that's how we do the chi-square,
Mm-hmm.
right? That's what it's saying. And there will be an equal amount. So let's say there's 50, right? 25 of them have positive values that are going to be subtract from the expected value. Then there are 25 that have negative values that you're going to be subtracting from the expected value. Does that make sense?
So 25, wait.
No, no, I'm giving you a hypothetical like there's 50 like there were 50 trials, right?
Mm-hmm.
That's what they mean by an equal amount, right? There were half of them were positive, half of them were negative.
Okay.
You so do you see two question part 2 here is referred to is using a chi-square test. But you just said it yourself. It's not supposed to be a chi-square test, correct?
Mm-hmm.
That's why 2 is not part of the answer.
Two is not part of the answer.
Correct.
Okay.
Okay? Now, we know one's part of the answer, two's not. What about three?
When 95% confidence interval for the population drug effect are constructed, those confidence interval include zero about 95% of
Can I ask you a different question?
yes.
What does the this part mean? Include zero. What does the value of zero mean?
I think zero is like the difference between two proportion. So drug has the same effect as a placebo.
Which means what? What does this? What does the placebo mean? No,
No,
no effect, right?
yeah.
So that's what the So that's what this means. Including zero means it includes having no effect about 95% of the time. That's what this sentence means.
Mm-hmm.
So is that correct? When 95% carnival in when 95% confidence interval for the proportion for the population drug effects are constructed, the confidence interval includes no um, no effect about 95% of the time.
Yeah, I think it is right.
Correct, because it has no because they said it right here. The drug has no effect. So the confidence interval has to have no effect in it.
Yeah. So what we choose?
So we know one is correct. We know three is correct, right?
Yep.
So even if you're worried about three, you know two is wrong, right?
Mm-hmm.
So you could already knock off. You could already knocked off B, and you could already knocked off D on the test. All you're left with is A. You're
Hello?
yeah, you're kind of worried about C, and it's not E.
But we said eight, one and three are both correct.
Yeah, it's one and three. Wow, why do they include two? Hold on. They actually include part two here in the solution. They said meaning the drug has no effect. Okay, I get that part. If the drug had no effect, we would expect the drug's effects mostly positive values. If we set a hypothesis up the first way or mostly negative values, it would be set up the second way.
Looks like
This is a bad question. This is actually a bad question. 2
okay.
and 3 would be good. Two Two's off. this makes no sense. They're supposed to reword this differently. So what they're saying here is that you can set your what would you could set your hypothesis testing in different ways. Okay?
Oh, I see. I see what they're saying. I see what they're saying.
So this part is kind of iffy. So but 1 and 3,
I
yeah.
see. I see. I
Okay.
see. There will be an equal amount. Yeah, yeah, yeah.
All right. 32.
32. Amber selected a random sample of 12 students in her major field of study. All students in the sample were asked to report the number of hours spent studying for the final exam and put their score on the final exam. A regression analysis and they produce the following partial computer output. For the slope of the least square proportion.
Are you watching the stream?
Yes, I am.
I pulled up a formula that you might need.
Oh, yeah.
That one?
Yes.
Yeah, that's the one you're going to be using.
Okay.
Okay?
Mm-hmm. Okay. Let me. So for this question, we have degree of freedom of 10.
Correct?
We want 95% confidence level, so it's 0.228, 2.228. We have I'll say this question is A.
Okay. First of all, okay, so all the answers have 2.228, right? So you know how to get that already? That's the
Oh
T
yeah.
star. Okay. The difference between all of them are the second value, right?
Yes.
How are
Yes.
you getting the 0.745? What does the 0.745 represent?
The standard deviation of the slope.
Okay. So where are you getting that in the chart?
We have it from study hour SE coefficient.
Correct. Do you know what the SE coefficient stand for?
Standard error
Error.
coefficient.
Yep. Right. So the margin of error is calculated, right? It's plus or minus the T star. The T star is from your chart, right? Or your calculator if you want to use inverse T. And SEB, right, is always given in the right here in the table, okay?
Mm-hmm.
Good? All right. So why is there no dividing by your n? Because look, like most of these answers have a divide by n, right? Or divide by
This
square root n.
this standard error coefficient has already been calculated, I think.
Yep, correct.
Yeah.
All right, good. Okay, there's nothing else that you need. All right, good job. All right, 33.
A mathematical competition uses the following score procedure to discover student from guessing on multiple choice. Oh my, this is like guessing penalty.
Yeah, but well, this is the same logic as why the SAT grades the way they do.
SAT have guessing penalties?
Yeah, well, the old one did.
Oh, oh, the O one did. Okay.
I know the AP test still has that.
AB tests have guessing penalties?
Yeah, the AP Euro test I know has it.
Oh my. Okay, this is savage.
Do you know what you're calculating, though?
Yes.
What?
Oh, hold on.
Okay.
Let me think. Okay. I'll say, uh, you can just eliminate one choice.
Okay. But what are you calculating? Like so how are you knowing which answer is correct in like what's your approach to question 33? What are you
So
calculating?
for each answer you eliminated your for each answer you eliminate for each question, your expected point for the question
Okay,
is
stop. So, you're doing an expected value, right?
yes.
Correct. Okay. All right. Now, talk me through the values you're using for your expected value.
Basically use 7 times for each choice you eliminated over 5.
Okay. So, your answer. Okay. So, did you calculate the one with five choices remain?
Oh, hold on. Wait. If hey wait, it's not 1/5.
It's not one fifth.
It's not. It's 1/4, I think. Yeah, it's 1/4. But it's still two. It's still uh, one choice though.
Okay.
Like for each choice you eliminated, your
Mhm.
expected point gain from this question increased by 7/4,
Okay.
which means if you eliminate 4 questions, you're guaranteed to get this question. It's 7. You get 7.
Okay. So you're basically looking for when the expected value basically gets right here because look, if you because okay, so let me help you think about it a little bit better, right? So did you see this sentence? The for each question left unanswered, the score is 2,
Mm-hmm.
right? So that's the bare minimum that you can do, correct? Like leave the question blank and you're going to get a score of 2. Does that make sense?
Mm-hmm.
So you're basically looking for an expected value that is greater than
2.
2, right?
Yes.
What is the
That's true.
first one that you calculate that has an expected value greater than 2?
1.
No, not 1. What?
Oh wait.
It's not 1.
What? Oh my God. I'm so bad. Okay. It's 2. Yeah. 1 is
Correct.
7/4.
Uh-huh.
7/4 is less than 2. Oh my God. I can't calculate.
All right. So the answer would be C, right? It would be
Yeah,
2.
yeah. C.
Yes,
Yeah.
because if 3 choices remain, right? The
Yeah.
probability, right? It's 1/3, 7, right? 1/3, and the other one is 2/3, right? The expected value
Yeah.
of 7 times 1/3 plus 0 of 2/3 is 2.33. That's the first expected value that is greater than 2, right? So that means if on a 5 question test, if you are able to eliminate 2, you should always, guess, right?
Okay. But hold on. Let me
hmm
let me flow the logic real quick here.
No, no, I could show you the math.
Okay. Okay.
Give you 1 second. Let me pull that up. All right. Okay. Do you see the screen? Tell me when you see
Yes.
it. All right. So the first calculation here is the expected value if there are five choices remain. Right. That was
Mm,
1 point. Right. Does that make sense?
mm-hmm.
7 times 0.2. Okay. That is bad. Now, the one you were doing is, let me change the color to red. Let me change it to green now. Right, is this one. Right. So when you have seven choices, okay, but this time it's 1/3 because you can eliminate two, right?
Mm-hmm.
And the other one is zero, right? The value of it is zero, and that's 2/3. Does that make sense?
Mm-hmm.
Okay. So you do expected value. 7 times 1/3 plus 0 times 2/3. 7 times 1/3 is basically 2.33. The expected value here is greater than 2.
Okay.
Good? That's the math.
Good. Good.
Okay?
Yep.
Alright. 34. Oh, so this is the reason why a warranty is bad.
What is
Right
warranty?
here. A warranty is like if the machine
Oh.
right here.
Oh. Yes.
So let's
Okay.
say you buy a new microwave, right? And they give you warranty for 2 years. That means if it breaks in the first 2 years, the company will
And
replace it.
yeah.
Okay.
Yeah. Yeah.
The probability that a new microwave oven is damaged during delivery and stops working less than 2 years is 0.04. The probability that a new microwave is damaged during delivery is 0.10. Given that a new microwave is damaged during delivery, what is the probability that it will work in less than 2 years? Do you know what type of problem this is?
Hold on.
Okay.
Your microwave stopped working less than 2 years. 2.05. New microwave is damaged during delivery and stops working. How come it's like the damaged microwave works generally works longer than the undamaged microwave?
Are you asking me a question in general, or are you asking me about this question?
Like the common sense.
Because something can be damaged but it can still work. It's like your, let's say you drop your phone, right? It's damaged, it can still work. It stops working maybe after like, so many years after it's damaged. Being damaged doesn't mean it stops working,
Mm-hmm.
right?
But this one is interesting.
Let's just, So if you're watching the stream, I just type down the information that you have, right? You have the probability of stop working, which is 0.05. Then you have given that you have a new microwave is damaged during delivery and stops working, okay, is 0.04, which is the second one. And the probability of it being damaged is 0. Uh, right? The probability that a new microwave is damaged during delivery is 0.10. So I have those up. Okay. The question is asking
Oh,
to. Okay, hold on, hold on. What did you extract the information correct? Because you're saying,
oh,
oh,
I
so
get
you.
it now. I get it now. I get it now.
uh, What were you trying before?
Oh, I tried to draw the tree diagram,
The
but I think it's
tree.
useless. Yeah,
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 no tree. Like you could have done a Venn diagram.
yeah. Venn diagram. Yeah, I'm doing a Venn diagram now.
Okay, but okay. I'm just gonna write. You're going to find.
Stops working in less than 2 years. Is this? Wait, what?
How do I do a bar?
Oh,
Oh.
I is this D 0.04?
How did you get
A
that?
point four.
How did you get that?
So you draw a Venn diagram. The
Uh huh.
probability of the microwave stop working is 0.5,
Okay.
and damage and stop working is 0.4. So there's a part in stop working that takes up 0.4 of 0.5.
Okay. I think I see it, but I don't have the Venn diagram on me. I why won't it? Are you watching the live stream?
Yes.
Okay. This is the way I did it. Uh, over that. Ah, what do you mean does not include brackets? Ah, this is how I did it. So the stopped, given that it stopped working, right? Well,
Mm-hmm.
hold on. Given that sorry. This is given that this should be damaged. Given that it's damaged,
Mm-hmm.
did it, what's the probability it stopped working, right?
Mm-hmm.
This is the same thing as the intersection of damage and stop working, correct? So I
Mm-hmm.
basically did conditional probability.
Mm-hmm.
So over damage. Does that make sense?
Mm-hmm.
Right? And I already have this value. This was 0.04, and the bottom one was 0.0.110. Oh, and this should be 0.110. There you go. Then when you calculate it, the answer, right, is zero point 0.4.
Mm-hmm.
Okay. Yep, that's it. So that's how you would do it in a like using the conditional probability. But if you did Venn diagram, that's basically the visual of the conditional probability.
Mm-hmm.
Okay?
Yep.
All right. 35.
Perchlorate is a chemical used in rocket fuel. People who live near a former rocket testing site are concerned that perchlorate is present in consumption drinking water. When the areas or less.
Of 28 water sources in the area produce a mean measurement of 25.3. Which of the following is an appropriate yet alternative hypothesis that address this concern?
D, HA, mu greater than 24.5.
Okay, why are you not using 25.3?
Because this is like the mu is a population mean. It's not a sample mean.
Correct. Good. That's it. All right. Why
Yeah.
why can't you use E?
We're gonna prove that it is unsafe for the people only when it exceeds the standard.
Good. So it becomes a one tail test, right?
Yeah, one time.
All right. Good. All right. Just just double checking, making sure you get 36. Ooh, what is this? 19.0 for the
Mm.
coefficient.
B,
Hmm. How did you get B?
because X here is lead and Y here is zinc.
Good. And this is the exact. Remember how I gave you that sheet about the sentence frame?
Yes,
Right? You see
yes.
how it follows exactly the sentence frame?
Mm-hmm.
Right, correct. And remember, it's on average. You have to mention that on average.
Okay.
Right, good. Okay. Remember, that's how we interpret the coefficient, right? We have to always say on average. Okay? All right,
Mm-hmm.
good, good, good. 37.
There were 5317 previously owned homes sold in a western city in the year 2000. The distribution of the sales prices of these homes was strongly right skewed. Right skewed. With a mean of this and a standard deviation of that, is it possible to
Computed for each of the samples, which of the following describes the sampling distribution of the sample mean? Normal with that mean.
A?
Okay, first of all, why did you not say it's skewed?
Because uh it satisfies the what is that called? N is greater than 30.
Which is called
What is that theorem? The what?
central limit theorem.
Oh yeah, central limit theorem.
Alright, good. Uh, because 100 is greater than 30, the central limit theorem is satisfied. So we can assume that the sampling distribution of the sample mean is approximately normal. Alright, how did you get, so that's how you could knock D and E off. How did you figure out the standard deviation?
S over root 10.
Alright, good. Okay, alright.
Yeah, actually I got one more questions.
Yes,
So the standard deviation here is 37,000.
roughly, yeah.
Yeah, but when your sample size is approaching the population size, the standard deviation is like super, super small.
Well, it gets, wait, say that again, as your what approaches what?
Oh, never mind, never mind, never mind.
Uh,
I get it.
you sure?
Yes.
Okay. Alright. 38. Wait, what did you just get? Hold on. What did you just get?
Get for what?
For number 37, like you said, like, ah, I get it now. Well, what
A.
did you get?
Oh, so the formula is S over root n, right?
Uh-huh.
When n is approaching the size of population, the S
Mm-hmm.
is the standard deviation here is super super small.
Yeah. Why is that mathematically?
Uh, but it should be like approaching the standard deviation of the population.
Correct. And why is that true mathematically in the formula? As n gets what? Bigger, right? It's the
N gets
denominator.
bigger.
Yeah.
Yeah.
Right. Because it's in the denominator. All right. 38.
Um, a
Sentence frame.
physician
Yep.
believes that the exercise habit of East Coast adults are different from the exercise habit of West Coast adults. So this should gather information from both factors. Okay.
Be a null hypothesis. Ooh. Keyword here. Keyword here. There's a
I
keyword
think
here.
it's B.
Why?
No hypothesis is a hypothesis of no difference, so it should be the same.
Yup. Right. Right. Are different. So your null is the same. Good. Right. Because you're trying to prove, right? You're trying to
Mm-hmm.
prove that there is a difference. Right.
Mm-hmm.
Ooh, 39's pretty. You're gonna have fun with 39.
Okay. For roll of a fair dice, 1 to 6, 1 to 0, 5, 6, red die and green die rolls simultaneously, and the difference of the outcome, red minus green, is computed. I think it's gonna be C.
How did you get? Why do you say C?
First, like your curve should be normal, approximately normal,
Okay, why?
because it's like a proportion probability.
Okay, but that's not. If this is a free response question, that would be a partial answer. You're correct, but you're not giving me the complete answer.
Mm,
There's more than because there's 50 rows and it's a proportion. It should be normal. There's more to the answer than that. Why is there like why? Okay, if I made this like B is also normal too, right? Doesn't B look
mm-hmm,
normal too?
mm-hmm.
So why is C a better answer than B?
Because C has negative parts.
Okay,
Red minus can be
explain that,
negative.
huh?
Because red minus green
Uh huh.
can be negative
Okay.
when green is greater than red. So the x-axis should be covered from negative to positive.
Okay, that's good. Good. All right. Anything
So
else?
it's in C and
So
D.
why zero? Because B, they're saying what 6.5 is the like median mean, and
Mm-hmm.
C is saying zero is your mean and median. Like why do you think C? Using that logic, why do you think the mean and medium should be around zero?
Because because the expected value because the expected value get from the red dice is the same from the expected value get from the green dice.
Correct. That's it. That's what I wanted to hear. It's an
Yeah.
expected
Okay.
value. All
Okay.
right.
Okay.
Good. All right. Again,
So
because again, what happens if this is a free response question, right? You want to give a complete answer. It's a
okay.
you're comparing the expected values. That's why. Good.
Okay.
40.
Okay. The probability of winning a certain game is 0.5 if at least 70% of the game in a series of n games are won. Oh, I see. I think it's A, but it requires some mathematical proof
Sure. Okay, first of all, why is your intuition saying n equals 10?
because uh when n is 10,
Mm-hmm.
normally you will win 5 games, but if you win at least 7 games, you will win the prize. So 7 - 5 is 2, but in B it's like 10 and 14.
Okay.
So you're gonna have to win more games in a like a longer turn.
Okay.
Yep.
And what does what happens as n tends to like 100 or infinity in our case?
Oh, when n tends to infinity, the
Mm-hmm.
probability of winning the prize is 0.
Well, yeah, it decreases, right? Your expected value decreases,
Yes.
right? So to maximize the winning, you want what?
You want n to be as small as
Small as
possible.
possible. Yes, correct. Because you're trying to take advantage of the variance. Okay,
Oh, yeah, variance.
right? Does that make sense?
Yes, sir.
That's yeah. Number 40 is very beautiful because it teaches you how to gamble. It says that every single game in the casino has is built so that the casino always wins, right? An expected value, right? That
Hmm.
is that there's an expected value that the house will always win. The only way to win is that you take advantage of the variance, right? So you don't play a lot of times because if you play like 1,000 times, it's going to be in
Uh-huh.
favor of the house because the
Yeah,
expected value is
yeah,
in their favor.
yeah.
You only win if
That's
you
correct.
play the first like one or two, three, and just take advantage of the high variance.
Makes sense.
All right. So, okay, that's why A is the answer. There's some calculation, but I mean, to me, if you use that idea, you can just solve 40. All right, good. All
Yeah.
right, so that's basically it of the multiple choice. There's not like I can't give you the other multiple choice. Your AP, did you do sample tests in your class? Did you do
Yes,
other?
we have one. Yes.
Yeah, and it was a multiple choice, right?
What was it?
You did multiple choices in class, right? The sample test?
Yeah.
Yeah, because the college board allows the AP stats teachers like five of the sample tests that were given out. I only have I can only give you because this is on like YouTube. I only could show the 2012, which is a public exam. I can't give you the other ones because the other ones that are out, teachers are only allowed to keep those in their room. They can't make,
Oh,
yeah, the other ones that we have that the college board gave us, we can't show that outside of the classroom. They're not
I
public
see.
tests. This is
I
the
see.
only public one.
I see. I
Okay.
see.
And the
Okay.
free all the free response are public too. But the
Okay.
multiple choice they try to keep together. So that's it. That's all. I mean, that's all we can talk about in terms of the multiple choice. Do you have any Do you have any other questions about the multiple choice part?
No.
Okay. So do you sort of see there's not a lot of math, right? There's not a lot of calculations involved. Have you noticed that?
Mhm.
It's a lot of,
Yeah.
right?
Logic.
Yeah, yeah, right. And again, the sentence frames are very important. Okay,
Mm-hmm.
in some of the answers. So, do you want to finish up this by looking at the multiple choice, or do you want to go because I also sent you the review 3, which is just free response again. Do you want to finish this free response, or do you want to go to
Hold on.
the free response I gave you?
Hold on. Give me 1 second. Yeah, let's do some FAQ.
So in terms of the FRQ, do you want to finish the 2012? Like you want to go do that FRQ, or do you want to go
Sure.
to the FRQ that I gave you that has a bunch of random stuff?
Bunch of random stuff?
Well, it like because last time you told me you just want like a bunch of like hard ones and
Yeah,
weird ones.
let's go for one.
You want to do that one?
Yeah.
Okay. So it's the one I sent you. You might it's the review 3. Do you want me to resend it?
Review 3?
Just
Uh,
check. Yeah, just check your email for anything you got for me.
Wait, what's our email again?
Here, I can just forward you it one more time.
Okay,
Uh,
thanks.
G What is that? You know how your extension is .atme.com? What is the atme.com?
It's iCloud.
Oh, okay. All
I
right,
just type. Yeah,
I
nothing
sent it,
special.
or I forwarded it to you again. Tell me when you get it.
Yep, have it. Okay. I have it now.
Yep. So we're just gonna work through that.
Sure. Many years medically accepted practice of giving.
So the first part is to interpret what the p-value measure in the context of this study. I need you to give me word for word how you're gonna answer it.
Oh my, p-value. This is a big one.
Yeah, this is like the eighth one we did in terms of interpreting the p-value, so you should know it.
Uh-huh. Have we done many about the p-value?
Yeah, we've done a lot of p-value questions, so you should be able to give me this one.
Let me think about it. Mhm. Uh, I know how to do the confidence level and confidence interval for
You don't
p-value.
need to do that for A. I just need you to interpret it.
I don't.
I need.
Yeah.
Mhm. There's, so what do you start with, and what do you need to mention to get the full points here? Do you need help?
Yes, please.
Okay, so you want to start off by saying the p-value of blah blah blah, so the p-value of 0.0761, okay,
Mm-hmm.
measures the chance of. So you have to mention that part. Measures the chance of. Because remember, this is a probability. Good?
Mm-hmm. Mm-hmm.
Okay. What does the p-value measure the chance of what? What does it measure here? The chance of what?
The chance of the survival rate for two treatment are equal.
Okay, good. Right? Now, but what, okay, now, so, period, what does the 0.076 means? Do we reject or uh, do we reject or do we accept the null? No, yeah.
We we do not we fail to reject.
Yes, so what does fail reject means? We fail to reject if the survival rate for the two treatments are in fact the same. Does that make sense?
Mm-hmm. Mm-hmm.
So you have to mention that part too. So you have to
Mm-hmm.
give those two to get the full points.
Oh, so we just mentioned the ch the chance
Of insert
of
what? Insert your.
H naught
Mhm.
is true is 0.07.
Yes, but you can't say H naught. You would actually have to write what H naught
Yeah,
means.
I know, I
Okay.
know.
Mhm.
Okay.
Good.
And so we reject H naught, which
Mhm.
is the survival rate of two treatment are equal.
Mhm. Mhm.
So this is the definition of P.
In the context of this question, yes.
Okay,
But
sure. Okay.
yeah, right? Because that's what p-value is supposed to tell us. If we reject or right, if we reject or not reject H naught based on probability. That's why I'm telling you you have to mention the word chance,
Chance. Okay.
right?
Okay.
Also, you have to include the word as large as, right? Or a large amount. Okay? Because this is a because you have to mention the normality, right? There's 518.
Oh, I have to mention the large sample.
Yeah.
Can you say that? Like, can you say the whole thing again?
Yeah, so there's different ways of saying it. So I would say uh, the given that there are 518 cases, the p-value gives a large measurement of the chance of H naught, right? Whatever our H naught is over HA. Okay, we concluded that the fact that the p-value is 0.0761 and it is below, the that 5, we can say we can reject H naught in favor of HA,
Hold
right?
on. What did you mean by large measurement here?
Oh,
Large
because
measurement, you mean P is
no, because the sample size, the n is greater
sample
than
size.
100, right? Because we the reason why I have to mention that is because we need to tell them that it is a large sample size. The n is greater than 100.
Mm-hmm.
No or yes? I can rephrase.
Okay. So I'll say this again, and can you check me if I'm right or wrong? Okay.
Okay.
So I uh, given there are five one 518 cases
Okay.
in the treatment, uh, the p-value the p-value uh, like the p-value in a large repetition of the
Kevin?
correct. I say that. Oh,
Yeah, you're cutting off, dude. Hello? Is that mine or?
Hello?
Yeah. Hello?
Yep, can you hear me?
Yep. Repeat your answer. Or like you cut off, that's why.
Okay.
But
So,
you said the first part correctly. I got the large part, and so keep going.
uh, after the large part is and the chance that H naught is correct is the p-value,
Okay.
and because p-value is greater than our significance level, we reject H naught.
Yeah, okay, that works.
Okay.
Alright. B.
Based on this p-value and study design, what conclusion should be drawn in the context of study? We reject H naught. We reject the survival. Oh wait. We fail to reject the survival rates for the two treatment are equal
That would be a partial answer.
because p is greater than alpha.
Now that's an essential. That's essentially correct.
Okay.
Good.
Yes.
There's always needs to be a linkage. There is always a. Without the linkage to the p-value, it would be a partial. Okay.
Okay.
Kevin, you're cutting off again.
Can you hear me now?
Yeah. Good.
Yes.
Okay. So C.
See, based on your conclusion, type one.
This is why I included this problem. You have a hard time with errors.
Oh yeah. Mm, we failed to reject. I'll say type 1 error.
What would be the type 1 error?
Type 1 error is uh when you reject H naught when H naught is incorrect.
But what does that mean in the context of this question?
Uh, we reject the survival rates of the two treatment for the two treatment are equal when they are actually unequal.
When there is okay, yeah, yep, that would work. That would be you. Yes, you gave me the name of the error, and you gave me the it in the
Consequence.
context, and that is part, and your answer is in line with your part B answer. So yep, that would be fully correct.
Mm-hmm.
Okay, good.
Mm-hmm.
All right, there you go. I also included how it scored for you to see that. Um, let's go. Yeah, let's do the next one. The professional sports team evaluate players.
The answer key, like in
Say
the
that.
answer key for the p-value, it mentioned as large as, so it's basically like the large sample. You want to mention the large sample.
Yes, or a word. Yeah, that's why saying the 458 is like that would be mentioning it. Hello? 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 And he cut off. It's not my internet. Let me run a CMD. my internet. Hello?
Hello?
Are you good?
Yes. Yes.
Alright. Okay. So we're on the a professional sports team evaluate potential player question.
Mm-hmm.
Okay. So work through part A. You are based on the relationship between the mean, standard deviation, and minimum time, is it reasonable to believe that the distribution of a 40-yard running time is approximately normal?
No.
Okay, so how do you get the answer with no?
Mm, because I think this one. Oh, let me think about it.
Do you want me to give you a hint? You want
Because
to?
the minimum is only approximately one standard deviation from away from the mean,
Okay, and what does that mean?
which means that uh
Something about the empirical rule. You could answer it in the empirical rule, or you could answer it in z-score. Doesn't matter.
this score. I'll use the z score.
Okay.
So z score is 1.33.
Okay. Wait, what?
And
Negative
then
1.33.
yeah, negative
Okay.
1.33
Okay.
because the minimum occurred at a z score of 1.33,
Okay, and what does that mean?
which is really close to the mean.
Okay.
So the relationship is not normal.
Correct. Because the distribution from the z-score shows it's not normal. So, yep.
Yeah.
Good.
Yes.
I would have just done the empirical rule, right? Do
Okay.
4.60, then show the standard deviation, right? So you go, I think the next one would be one standard deviation below would be 4.40? No, 35? No,
What was it?
45. One standard deviation below the mean is 4.45, right?
4.45.
Right?
I don't know. I think it's 68, 97,
No,
99.5.
no, 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 no. I'm giving you the exact value. If the mean is 4.6, the standard deviation is zero point 0.5, right? So if you go
Yeah.
one above, one standard deviation above, it would be 4.85. If you go below,
Oh,
it's
okay.
4.45, right? Do you see how it's
Okay.
already one standard deviation, like, right? Too small, right? If
Mm-hmm.
you look at the live stream, you see the picture, right? This is
Oh,
at 4.45, and right?
yes.
And if they're saying the minimum, which is going to be my red, if the minimum is 4.40, right, that means the cutoff here is right here, right?
Mm-hmm.
Is this graph here, right? Is that normal? No, that's our skewed, right? Do you
Yes,
see
that's
that
good.
visually
Mm-hmm.
using the empirical?
Mm-hmm.
Okay. All right. B.
Mm-hmm.
Now you interpret the z-score. No, now you calculate the z-score.
But I can still mention. calculate and mention this score in part A, right?
Yes, you can show that as your reason, yeah.
Okay.
Give me exactly how you mentioned B and I will tell you if it's partial or fully correct.
Okay. So the Z score here is 2.4, which means okay, hold on. The Z score here is 2.4, which
Uh-huh.
means the weight he can lift is 2.4 standard deviation from the mean, and the weight he can lift is greater than 99.18
Wait,
of the
what?
amount of the total
Wait,
sample.
say that. Wait, say that again. What's the max he can lift?
The weight he can lift
Uh-huh.
is greater than 99.18%
What?
of the people in the sample.
Wait. The last part makes no sense. He can, because okay, give me the last sentence again.
Huh?
No, give me your last sentence about that 9.9 something.
99.18%.
Yeah, why are you giving me a percentage?
Because I'm calculating the Z-score and I find the Z-score on the
It's
table.
okay. You don't need to give that percentage though.
I don't need? Okay.
Yeah, because that percentage is uh, like
Because I want to help it. I want it to help me to interpret the Z-score.
yeah, but interpreting the Z score is um saying like the max he can lift. So you would say like the max he can lift would be what's 2.5. So that's 360, right? Or wait, hold on, 25 times a half. So point 12 point. So the so this player should be lifting on average 372.5 pounds. Does that make
Mm-hmm.
sense?
Mm-hmm.
Because that is what 2.4 standard deviation is, right?
Okay, can you say that again? Can you say
Okay,
that again?
you said 2.4 standard deviations, right?
Yes.
Each standard deviation is 25 pounds, correct?
Uh-huh.
So, what is 2.4 times 25 pounds?
60.
Yeah, you add that to. Wait, what? No. No, it's not. 2.4 times 25 is 60. Yeah, you add that to the 310.
Mm-hmm.
Do you see that?
Mm-hmm.
Okay, that's what it means in terms of a player that lifts 370 pounds. Okay? You could talk about that. Let me pull up the grading. Hold on. Let me pull up the exact grading for that one. Question one. Let me see if you get all parts of it. Hold on. Uh, okay, let me see here. Part B. So you gave me the correct Z-score and private a correct interpretation. That includes the direction. Okay, what? What? Okay, they say that includes the direction. What do they mean by direct? Positive, positive, positive. So what does the positive Z value mean?
Positive Z value means like above other players.
Yeah, okay, yes. That's what they mean by interpret the. So you have to give both the z-score and the context, which you did, but you also have to include the direction, which means it's above the players, right?
Okay.
It's okay.
Okay.
That's just how they wanted graded.
Okay.
Okay.
Understood it. Okay, got it.
All right. C.
The characteristic of speed and strength.
Considered to be an equal. Like a player for the based on the information about the means, speed, and the strength data for all players. The measurement lie list in the table for A and B. Which players should the team select if the team can only select two types of players? Justify your answer. Are you calculating it or do you need help?
I'm calculating it.
Okay.
Okay, cool, cool, cool.
To the adjusted scale.
I'll say player one, player
Okay.
A.
Okay. Is that your fun? Like, is that all your answer for that question?
Nope.
Okay.
I calculate the standard deviation for each block here,
Okay.
and I find the total standard deviation for the player A is 3.6 and 2.8 for player B.
Okay.
So because player A is generally uh more generally more higher score than player B.
Keep going.
So so we choose player A.
All right. You would get only a partial answer because you did give me the correct what player, but the justification is not using standard deviation. The justification needs to be a comparison of the z-score.
I mean, not standard deviation. Oh my God. Z-score.
Okay.
Z-score. Yeah.
Okay. All right.
I thought
Now,
the Z-score for total Z-score for A and total Z-score for B.
okay. Did you combine them or what did you do? Because these are different categories,
Oh.
right? Your the time to run a 40 would be one Z score for player A and another Z score for player B, right? Then you
Mm-hmm.
would have to do another Z score for the weight.
Yeah, I have them separately, but I ultimately I added them up
Wait, why would you add up Z scores?
because this is like their performance.
No, no, but you don't add them. You compare them separately. You don't add Z scores.
I mean, I did score for A
Uh huh.
player A's Z score on running and lifting.
Mhm.
Remember the Z score for player B?
Okay. Okay. First. Okay. Never add Z scores. Okay.
Sure.
Keep it separate, and let's just talk about. I, yeah. Okay. And let's just talk. Yeah. I don't want to spend time about explaining why you shouldn't add Z scores, but let's just talk about player A, right? You got a what? Negative 1.2 for that Z score for the running, and you got negative 0.2 for player B, right?
Uh-huh.
Which one do you prefer? Just looking, if we just look at the 40-yard run, which one's better?
Player A.
Why?
Much better.
Why?
Because its standard deviation, I mean, the score is much smaller than player B,
Why? What does that mean? Like,
and we
what
want
does?
the player to run as fast as possible, so the
Correct.
least means the greater.
No, you should say that. You should say that he runs. Okay. 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 Yes. 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 You can say that. Okay. Okay. Yes. You could say that. Okay. What's one standard deviation? 90. No. 67.
68.
68. So he runs faster than 68% of the players.
Actually, if it's one tail, then it's 34%.
Okay, 34. Okay, yeah, okay, 34. Yeah. All right. Okay. But the other person that has a point two is what? Right? Not that special, right?
Mm-hmm.
Okay. Now, let's look at the weightlifting, right? Their Z scores were very close together, correct? The first player A was 2.4 and player B is 2.6. What does that mean?
Which means player B is slightly better than player A on lifting.
Hmm. But is that gap is there a big gap between their weightlifting
No,
strength? No,
no,
right? So is that a good measurement that we can like do we care?
no.
No, right? You should only care about the time to run the 40-yard dash because the Z score range is larger.
Mm-hmm.
Okay? You have so to get the complete response is that you have to give the picking a player A, you have to mention the Z score, and you also have to mention the Z score range to get the fully correct answer.
Mm-hmm.
Okay? Good?
Okay. Yes.
Alright. So I don't know if this is partly true, but it is always better to give more information than to put less information on the answer.
Okay. Okay.
Right? But don't write gibberish, okay? Right? Okay.
Okay.
So here's the let's go to question 3. This is the airline claims. Are you working on it?
Yes.
Okay.
Oh my god, this one, I remember this one so clearly.
Did
We
you work on
actually,
this problem before?
yeah, this is actually on our test. And C and C actually pissed me off that time.
Why, you don't like conditional probability?
I mean, I really did like 20 times of the calculation, the more than 20 upgrades. I did like 1 upgrades, 2 upgrades, 3 upgrades, up to 20 upgrades, and I use 1 to subtract all of them,
Uh,
and I get the exact answer for the one. It's like a huge project to do.
alright. Do you still want to work on it? Or are you okay?
Yeah, I'm working on
Okay.
it. Yeah, the first one, second one is quite easy. The first one is 0.09 times 0.09. Oops. After third flight, does it include the third flight?
What do you mean? No, they say the outcome is independent from flight to flight.
I mean, will occur after the third flight. Does it include the third flight? It doesn't, right?
No, an airline claims that there's a 0.10 probability that a coach hold will fly frequent will be upgraded to first class. It's independent, semi-frequent flyer. No, so ask me the question again. Like, so if he gets upgraded during the second flight, does it affect the third? Is that what you're asking?
No, I mean, hold on. No, no, no. I'm just on the question.
Mm-hmm.
What is the probability that Sam's first upgrade will occur after the third flight? So does it include the third flight?
Yes, wait, hold on. No. Will
It
occur.
does not
No,
include it.
the word
Okay.
after means yeah, 4. It starts at 4. So it's equal to or greater than 4. That's what the word
Okay.
after
Okay.
means.
I have 0.719 for the A.
Yay! Correct. Right? Say ready, Ethan? Correct. Do you see the baby on the screen?
What? Oh yeah.
Yay! Correct. Good job. Okay. Do part B now.
Is he your child?
No, he's my nephew.
Oh, nephew. Okay.
Yeah. Just 5 more minutes. I take him down.
Okay. It's okay. I'll probably.
What's the probability that it will be exactly 2 in his next 20 flights? What type of problem does B? What type of problem is B? It has a special
Binomial.
name. Yeah.
I have 28.51.
Okay. Right.
0.2851.
Yeah. Right. That's a straight binomial, right? 20 choose
Yes.
2. Okay. All right. Part C. So okay, hold on. Do you know how A and B? There's no like interpreting, right, or explain, right?
Mm-hmm.
So when you do it, you just write the calculation and you just go on. That's it.
Okay.
All right.
Okay. Okay.
So part C. Sam will take 104 flights next year. Would you be surprised if Sam receives more than 20 upgrades? Do you know what that word surprise means?
Like very small chance.
Well, if you're surprised if a small chance, yeah, if the small chance occurs, yeah, right. Because if something has very low probability and it occurs, you would be surprised.
Yeah.
Okay.
I think I need help on this one.
Okay. So let's. So will you be
Can we
surprised?
calculate
Yeah.
if it
So what does the word receive more than 20 flights mean?
when n is greater than 20?
Yeah. So how about you do the how about you give me that probability? That the probability of him receiving more than 20 upgrades.
I don't know how to do it. I mean how to do it like fast. Hello?
Yeah.
Do you know
Uh
how to do it on calculator?
20 20 20 20 20. What about 20 wait, hold on. If 20 choose 20? No.
Huh?
Oh no. If Sam receives more than
It's basically do part B 20 times.
no. No, what is it? CMD. No, no. The continuous function part. Let me see. Let me see. Um, no, you're basically doing part A like 20 times, right? It equals to 1, it equals to 2, it equals to 3, and you're adding
Yeah,
all those up. Yeah.
yeah, this is what I did.
Like, give me 1 second, okay? Be right back. Be right back. Oh, you are? Okay. He's right there in his car. Alright. Kevin, you there?
Yes,
Okay.
yes.
Let's see. Would you be surprised if Sam received more than 20 their flight? Okay. You're asking, is there a shortcut for the 20? Yes, yes, yes. Hold on, let me think. Um,
Uh, I think
CMD.
there's a one way on calculator.
What is it? What is it? What is it? Hold on, hold on. It's in. Yeah. Hold on, hold on. Let me pull up my book. Uh, mm, I should know it on top of my head. It's when you're adding a bunch of expected values together. No, no. Let me just go to stat. Calc. No. Test. No. Interval? No. Calc. Hmm. Hold on. Hold on. That's a good. Hold on. Value be 1. 0.01. Can I do that? 0.1 to the 20th power? No. Hold on. Cumulative, cumulative, cumulative. What is that? It's a cumulative. Hold on.
Yes.
Hold on. Zero, 0.1 plus
Are you using a
0.
calculator?
Yeah. To the power of x. And I would just have to cumulative it. start at 1, go up by the value of 1. This looks off. Wait, 0.01 plus. Oh, no, no, that's what I forgot. Insert square, close it, times 0.1. 0.112. That would still be off. Wait, you would have to add them all up. There has to be a shortcut to this. So, this is the way I did it in my calculator. So, let me show you. So, do you see, are you looking at the live stream?
Yes.
Okay. I go to, on your calculator, let me pull up a, so do you know where, stat plot, do you know the y equals under
Mm-hmm.
stat plot?
Oh, you use a graph.
Yeah, I cheated. So, well, not cheated, but I basically did your 20 times, but just
Mm-hmm.
using the calculator,
Okay.
right? So, no, no, because there is a way to do it, but I don't know it off my head. So I'm doing it like a very blame way. So what I
Okay.
did is I plotted zero point 0.1 plus parentheses, parentheses. I basically, here, let me write it out. I plotted this. Mm, where's the... I basically plotted that, right? That was each one of the probabilities, correct?
Mm-hmm.
Right? And so there was a, then what I did is I went to table, then you go to table,
Mm-hmm.
right? And it was right there, right? So you
Oh,
start with 1,
yeah, you have everything.
yeah. Then I would just like add those up,
Okay, got it.
right? That's how I would get my 20. But there is supposed, because it, because this is just binomial though,
Yeah,
right?
I'm gonna ask my teacher.
So there's supposed to be a binomial part.
Yeah.
Hold on, let me try to look in my book. There is supposed to be a binomial way of doing it in the calculator.
Mhm. Actually, do you have time next Wednesday?
Yeah, no, yeah, yeah. Wednesdays I'm free. Yeah. When's the
Wednesday,
test?
it's on Thursday.
Yeah. Okay. What do you want to do on Wednesday?
I don't know.
Binomial, 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 binomial table, binomial. Is this a binomial random variable or binomial probability distribution? Hmm.
Do we have any
204.
suggestions?
Hold on.
Okay. Okay.
Because I'm looking through my book right now. Look, like,
Okay.
right.
Alright.
Because it's really good at it gives you how to they do it with a calculator. Okay. Yeah, Pim. Huh. They. Hold on. Hold on. This might. Yeah. Hold on. Let me just do this for you. Let me take a picture of this. Right. And let me send it to you now. What is your last? What's your phone number? What is your phone number? Hold on. Don't say it. Don't say it. Don't say it. Because we're on the internet. Um. I'm gonna send you. I'm gonna send it to you. Okay. But
Okay.
yeah. Oh, okay, right here. me send the first one first. All right. Okay. There you go. It's being sent now. But that's to compute probability K, success in N trials where P is the probability, right? Right? Yeah.
Have you sent it? Have you sent it?
Yeah, it's being sent right now. Yeah.
Okay, got it.
Because this is binomial, right? Yeah. That's the only binomial stuff that's in the calculator. Did you get it? Or are you still opening it?
Open it.
Yeah, so you would use something like this. It's a binomial CDF. That's the function. You want what? In this case, it would be 20 trials. Or the
Oh,
look at part two. I think that's what you're looking for.
oh yeah, I have it on my. I googled it. I found it. Oh my, I'm stupid. I actually found it 5 minutes ago, but I thought it was like a given number, but it's not at least. But actually, it is.
Yeah, no, no, no. Because so do you have the picture up?
Yes.
Yeah. So when you have the at least, look at part three. You're basically using that you can like look at the part three. You can use the one minus binomial CDF.
Okay.
Yeah. So
Oh,
yeah.
binomial CDF. Okay,
Yeah.
got it.
Yeah. That's it.
All right.
There
Thank
you
you very
go.
much.
So what do you want to do next Wednesday?
I don't know. I haven't decided yet.
Okay. How long do you
If,
want it
if
for? And what
uh,
time?
I will let you know before Monday if I
Okay.
want to have a class on Wednesday. Okay?
All right. Just let me know.
Yeah. Do you have any suggestion for me on the test?
What do you wait? What do you mean? What?
Like, uh,
How
some.
best to study? What are you talking about?
I mean, like some stuff you think I'm weak about.
Um. Well, there's not okay. Let me give you like an honest reflection of like how you've been doing. Like, there's not a lot of mechanical mistakes that you've been doing, right?
Okay.
The multiple choice, you're good you're good at interpreting the question. You can recall the information fairly quick, right? And
Mm-hmm.
you can apply it, right? The
Mm-hmm.
only times that like the only like stuff that you're like kind of iffy on is just how well do you like how much do you need to explain on the explain part,
Okay.
right? That's the only part that like I really had to talk to you about. But mechanically, I think we covered every single mechanical topic, right? We covered
Mm-hmm.
hypothesis testing, confidence interval, regression. Like we did a bunch of z-score stuff the last couple of days, intervals. So I mean, maybe like the only thing that we haven't really talked about is the graphs, and I think you're fairly okay with the graphs in terms of like looking at a boxkin whisker. There weren't a lot of if you looked at the multiple choice questions, there aren't a lot of like pie charts or bar charts, right?
Mm-hmm.
So you're fairly okay, but I think we covered everything possible.
Okay.
So it's up to you on how you think you feel. You haven't made mistakes that I'm like freaked out about. The
Okay.
only mistakes you've been doing is, the small things like the last thing was like compiling the z-score, or when you're calculating it using the z-score, or
Okay.
sometimes it's the empirical rule, things like that. But you're fine mechanically, so
Okay.
okay.
All right. Thank you.
All right. Let me know, okay?
All right. All right.
Okay. Take care. Bye.
All right. Thank you. See you. Have a good